In this video, I want to talk about specific heat capacities. So let's say we have a 1 gram object with the current temperature of 10 degrees Celsius. What would happen if we add some heat? For example, let's say we add 3 joules of heat to this object. Well, clearly, if we add some heat, we would imagine its temperature would increase. So in this situation, when we add 3 joules of heat, we would see its temperature increasing by 5 degrees Celsius. We would see its temperature increasing from 10 degrees Celsius to 15 degrees Celsius. But now let's say we have a different object. Again, let's say we have a 1 gram object with the current temperature of 10 degrees Celsius, but let's say this object is made out of a different material, and hence the different color. So now we have this different material, and again, let's say we add some heat. Let's say we add that same 3 joules of heat. Again, if we add some heat, we would imagine its temperature would increase. However, with this object, when we add that same 3 joules of heat with this object, its temperature only increases by 1 degree Celsius. Its temperature goes from 10 degrees Celsius to 11 degrees Celsius. So what's going on? Why with this material, when we add 3 joules of heat, we see a dramatic increase in temperature, but with this material, we add that same 3 joules of heat, but with this material, we see its temperature only increasing by 1 degree Celsius, a small change in temperature. Well, again, all materials have their own specific heat capacities. This material has a specific heat capacity of 0.6 joules per gram Celsius, while this material has a specific heat capacity of 3 joules per gram Celsius. And again, the point is, the lower the specific heat capacity, the easier it is to change its temperature. However, this material with the high specific heat capacity resists changes in temperature. So because this material had a higher specific heat capacity, we could add that same 3 joules of heat, but because of its high specific heat capacity, it would resist that change in temperature, and we would only have a small change in temperature. So again, whenever we're dealing with specific heat capacities, you should think about this formula. The amount of heat you add to an object equals the mass of the object multiplied by the specific heat capacity of the object multiplied by the change in temperature, not the original temperature, final temperature, the change in temperature. And again, just analyzing the units, Q would be joules, the unit of heat is joules, mass would be grams, temperature is Celsius in this example. So again, but we know this side must equal joules. So therefore, the units of the specific heat capacity must be joules per gram Celsius. So therefore, the grams can cancel, the Celsius can cancel, now we know joules equals joules. So again, that's just some unit analysis, pretty straightforward. But let's actually use this formula. So let's do an application of this formula. So let's say we have a 1 gram object. Let's say we have a 1 gram object with a specific heat capacity of 0.6 joules per gram Celsius. And let's say we had a certain amount of heat. We don't know how much heat, but we know we had a certain amount of heat, and we see its temperature increasing by 5 degrees Celsius. How much heat did we add? How can we determine exactly how much heat we must have added? Well, again, we know the mass of the object, we know the specific heat capacity, and we know that once we added this heat, its temperature increased by 5 degrees Celsius. That was the change in temperature. So under these conditions, the amount of heat must have been 3 joules. We could just solve this. We could just algebraically solve this, and we would get a heat of 3 joules. So again, what this tells us, if we have an object with this mass, with this specific heat capacity, and its temperature increased by 5 degrees Celsius, we must have added 3 joules of heat. That's the only amount of heat that could have been added to cause this change in temperature under these conditions. But really realize the way this formula works. It's arbitrary that this was 10 degrees Celsius and 15 degrees Celsius. Let's say we had a different example. Let's say everything was identical except, let's say the original temperature was maybe 20 degrees Celsius. Let's say we add some heat and then its temperature increases to 25 degrees Celsius. How much heat did we add? Add? Well, again, we know the mass is 1 grams. We know the specific heat capacity is 0.6 joules per gram Celsius. And again, we see the change in temperature was 5 degrees Celsius. So that delta T was still 5 degrees Celsius. So if under these conditions, to get a change in temperature of 5 degrees Celsius, we must have added 3 joules of heat. So that original temperature was arbitrary. That didn't matter. So it's important to understand this formula. This just tells us under these conditions, if we have this change in temperature, how much heat must have we added? And it doesn't matter what the original temperature was or the final temperature. All that matters was that change in temperature under these conditions. We can determine exactly the amount of heat we must have added. But again, so let's do one more example. Let's say we have a 1 gram object with a specific heat capacity of 3 joules per gram Celsius. And again, let's say we add some heat. Let's say we add some heat, and when we add some heat, we see its temperature increasing by 1 degree Celsius. So we know the mass of the object, we know the specific heat capacity, and we know the change in temperature. How much, once we added this heat, how much increased the change in temperature? 1 degree Celsius. So under these conditions, with the change in 1 degree Celsius, we can solve just algebraically what this Q must have been. And we can see this Q must have been 3 joules. If we have this 1 gram object with this specific heat capacity, the only amount of heat that could have caused a change in temperature of 1 degree Celsius, the only amount that could have caused this change under these conditions must have been 3 joules of heat. And that's the way this formula works. And again, it doesn't matter what the initial temperature was or final. All that matters was that change in temperature. So let's do another example. Let's say we have a 2 gram object with a specific heat capacity of 0.5 joules per gram Celsius with a current temperature of 10 degrees Celsius. And now let's say we have a different object that's at 10 grams. But let's say it's made out of the same material. It has that same specific heat capacity of 0.5 joules per gram Celsius. And again, let's say its original temperature was 10 degrees Celsius. Now let's imagine we add some heat to these objects. So for this object, let's imagine we add 5 joules of heat. If we add 5 joules of heat to this object, we know its temperature is going to increase. But by how much? What will be that change in temperature? Well, again, we know our formula. If you know the amount of heat you add, and you know the mass of the object, and you know the specific heat capacity of that material, you can determine what that change in temperature must have been. So again, in this situation, we know we added 5 joules of heat to the object, and we know we added that 5 joules of heat to a 2 gram object with this specific heat capacity. Now, just with some simple algebra, we could solve what this delta T must have been. We could solve what this change in temperature must have been. And again, simple algebra would tell us this delta T must have been 5 degrees Celsius. So this object's temperature must have increased by 5 degrees Celsius, so its temperature would increase to 15 degrees Celsius. But let's say we have now with this object, let's say we had that same 5 joules of heat. Again, with this object, we had 5 joules of heat. What would be that change in temperature? Well, again, we just use our formula. We know the amount of heat we added was 5 joules. So we added 5 joules of heat to an object that was 10 grams. Notice it's 10 grams in this situation. And the material has it's the same material with the same specific heat capacity. So under these conditions, what would be the change in temperature? Well, again, we just plug in what we know. We know the amount of heat we added to the object. We know the mass of the object and the specific heat capacity of the object. So again, some simple algebra, we could solve for this delta T. And if we were to solve for this delta T, we would get a delta T of 1 degree Celsius. So now we know this object, its temperature would only increase by 1 degree Celsius, and it would increase to 11 degrees Celsius. So what's going on with this? It's the same material. So when we had 5 joules of heat, this object temperature only increased by 5 degrees. It increased by 5 degrees Celsius. But with this same material, we have that same 5 joules of heat, but under this situation, the temperature only increases by 1 degree Celsius. What's going on? Well, again, we have a larger mass. We have a larger heat capacity, and we have a larger mass. So therefore, even though we added this with this small object, we had 5 joules of heat to the small object, and we get a large change in temperature, a large increase in temperature. But now we have a larger object. So we add that same 5 joules of heat, but we have a larger object, so we have more mass to heat up. Because we have more mass to heat up, that same 5 joules of heat is going to cause a small change in temperature because we have such a large mass. So again, we add that 5 joules of heat to the small mass. It causes a strong change in temperature. But again, we have such a large mass. So even though we add that same 5 joules, because we have such a large heat capacity and such a large mass, there's more mass to heat up. So it's going to cause a smaller change in temperature. So again, the point is, the way this formula works is usually you'll be given 3 of these variables, and then you'd be asked to solve the final variable. For example, maybe we know we have another random object. Let's say we just have this made up object. And let's say we know we add maybe 3 joules of heat. And let's say we know its mass was maybe 2 grams. And let's say when we add that heat, its change in temperature was maybe 4 degrees Celsius. Under these conditions, we could solve what the specific heat capacity must have been. But now, again, let's say we have a different object, and let's say we add 10 joules of heat. Let's say its specific heat capacity was 2 joules per gram Celsius, and let's say its temperature increased by maybe 5 degrees Celsius. Under these conditions, we could solve what the mass of the object must have been. So it's just some simple algebra. It's a pretty straightforward formula, and that's the way this formula works. That's the way specific heat capacities work.